sharding implementation. I'm in Taiwan, Taipei. And today I'm trying to use English in my presentation. So I'm kind of nervous here, but there's 3 reasons that I'm doing this. First, I do want more people to understand that. Second, apparently I need more practice. And third is that I'm showing you that you don't need perfect English to join a global team. Okay. So, hi, my topic is what you can do for Ethereum 2.0, a.k.a. Sharding. So there's so many people here, I'm very glad that. So how many people here are the developer or your job is related to the apps? A few? And how many people here are working on something related to the layer 2 scaling solutions? Oh, and how many people here are working on the layer 1 protocol? No? So here's your chance here today. In order to start from this, we need to know what is sharding first. And the second is, where can people start to dig into the sharding? And the third is that how can you actually contribute to Ethereum 2.0? So here we go. First, what is sharding? So we say sharding is the Ethereum layer 1 scaling solution. So the concept of layer 1 is that compared to the other layer 2 solutions like Plasma and state channels and Raiden. So this is the layer 1 protocol that we want to make it secure and decentralized. So there will be some trade-off between the scalability, decentralized, and security. So as the researchers and developers, we need to balance those trade-offs to make it good enough and better. So there's some terminologies here that the first is the main chain. So we say the main chain is the Ethereum 2.0 blockchain. So we can just think it's the blockchain, the mainnet that we are all using now. And the second one is the shard chains, also called the shards. So the idea is like the database sharding, that we will create many new chains for the Ethereum 2.0. And these whole new chains are still in the whole, they are the part of Ethereum whole universe. So since those shard chains are brand new, there will be a new genesis in every shard. So it gives us a chance to redesign the deep layer protocol from the base layer. So what we call our current sharding model is the Quadratic Sharding. So the idea is that assume that each computer can process C transactions. So the main chain can process C transactions, right? So this is the computation. So if the main chain can process C transactions, then we say that the main chain nodes have the ability to watch C shards. So let's say, oh, here is C shards, and then every shard has the ability to process C transactions also. So apply that to this, then we say that the whole system can process 2 squared transactions. So that's why we call that the quadratic sharding. So to solve this problem, it will take multiple phases. But our final goal is that to make it to be tightly coupled sharding chains. So imagine that there will be some proofs of the shard chains will be written into the main chain. So you can to think that simpler is that there's maybe some block cache of the shard chains will be written into the main chain blocks, and we will add some conditions to restrict that the main chain, if the shard chain blocks are invalid, then the main chain block which included the shard chain blocks proof, those main chain are also invalid.
So you only one shard that's invalid, then your whole block is invalid.
No, yes. If one shard block that included in black main chain block is valid, so then the main chain block is invalid. So yeah, we need all the shard blocks proofs are valid, then the main chain blocks is valid. Yes. Okay, that's our final goal. That's the fundamental difference between the layer 1 scaling solution and the layer 2 scaling solutions. Okay, and here's our recent R&D concept, but it might be changed. So the idea is that there will be multiple layers. Main chain, beacon chain, shard chain, and state and VMs. So from the bottom to from the top to the bottom, the first layer is the main chain. So we say that we need somewhere from the top layer that provides staking, which means that the current research is that we will have a special contract called Sharding Manager contract. This is a contract like do the Casper-like proof of stake. So there will be a shared validator pool in the contract. So if the Ethereum users wants to join the validator pools, they need to make a deposit on the contract. And then those validators will be sampled from the pool. And if the validator does their job well, they validate the block, they will get the rewards. And otherwise, they will be penalized. So some different actors' roles will be sampled from the shared validator pools, include that maybe shard chain proposers and notaries. Notaries can, to think simpler, it's the validators. And eventually we want to integrate with Casper. So it's important that for every shard, they share the same validator pool, because and they don't fully have knowledge that which shard they will be sampled. I mean, they don't the validator, they don't know which shard and which time they will be sampled, right? Because it's important, because if the validators know that knowledge, then it's easier that the malicious validators, the attackers, can conduct the 51% attack to some specific shards, right?
So shared validator pool is only one big giant pool.
Yes. So it's important that how to make the selection fair. That's why we need the random number generation. So the concept is that there will be a beacon chain. its job is to provide random numbers. So the beacon chain will be multiple blocks, and the blocks might grow faster than the main chain. So the beacon chain blocks, the growth speed like 5 seconds per block, per beacon block. And each block they generate one random number. So we use the random number to select the block proposer and the notary committees. So there are some in research schemes to generate the random number. There are the random best scheme and BLS best and stack best. And our current strategy might be we use the BLS best scheme for short term, and eventually we will use the stack best scheme for long term.
What's the size of the committee?
It's undetermined. Maybe there will be some small committee for each block, and there will be a big committee for the checkpoints.
Yeah, but what's the size? There are numbers?
In discussion, but last month is 400, this month is like 100, so in discussion. And there's the data layer. So it's very interesting that the ShardCoin consensus are just data consensus. The block bodies are just some blocks, the binary files. There's no problem. No problem. Oh no. Okay, so hello. Hello. Okay. So there's no state root in the header as we think that in the Ethereum 1.0 blocks. So the validators of the ShardCoins is they only need to deal with the data availability verification. They don't need to actually execute the EVMs. So what it gives us is that we can start to implement the ShardCoins without dealing with the state execution layer, right? And the job of the validators will be easier. So the simple validators, they can only deal with the current blocks, the recent blocks, and they don't need to deal with the state histories. Cool. And then the last is the state players. So currently there's some disadvantage of the EVMs. Like it's a 256-bit state EVM. So this design it's more difficult to mapping the EVM opcodes to the hardware instructions. And also, how we metering the gas, it may be different. The actual cost may be different between different client implementations and different computers. The cost of you execute the contract in the gas node may be different from you execute the same contract in the Parity node. So the cost is somehow different. So our most promising candidate of the EVM replacement is the EWASM, the Ethereum WebAssembly. Okay. There are another team called EWASM. You can check it online. Oh. now, and where can you start digging to? Oh, I list like 6 fields, 20 topics here. So you must have something interesting in here. Okay. So at the beginning is by the way, the roughly roadmap is that start from the left to right, from top to bottom. Probably. So if you want to know more about the sharding protocol, I recommend that people should read the Sharding FAQ by Vitalik. And there's the forum called the East Research Discourse. That's that magical URL. Virgil is a genius. It's East Research. And if you want to know more about the data availability, you can read the list article by Vitalik. And about something about the Casper integration, please read the Casper EIP first. And also, Chih-Cheng will introduce the Casper after me. Yay, Chih-Cheng. If you want to know more about P2P, maybe the latest research will be posted on its research too. And also there's the we are considering replace the dev P2P transport layer to leak P2P. There's some discussion on the leak P2P GitHub. And also Kevin. Hey Kevin. Kevin is working on this. Kevin in the house. Okay. And if you want to know about digital signature scheme, maybe you want to read the research. And the efficient accumulator is something that we may want to replace the current Ethereum Patricia tribe to other better accumulator. Maybe it's the sparse circle trees. And something about RLP encoding is that line might be too complicated for our usage. So we're also exploring some replacements. And the state execution, as I said, it wasn't there. We have GitHub here and can check online, and also we have the gitter. You can discuss and ask questions here. Oh, and account abstraction, our researcher so there are 2 different, slightly different account abstraction. One is on the main chain, one is on the shard chain. Nicholas, my favorite blogger. Where's Nicholas? Somewhere. Nicholas in the house. He has a site here. And about the account restriction, Yannick has a site here too. So account restriction is about that we restrict because now the contract they can have some logic to execute other contract inside their contract, right? So if we restrict that, people need to decline that which accounts they will access in their transitions. Then it will help us to deal with stateless client and also how to parallel execution. About stateless client, it's not 无国界客户端, it's 无状态客户端. So you can read Vitalik's research post. And about cross-shard transactions, maybe also start from Sharding FAQ. Oh, and about the engineering part that plasma cache is plasma. Trinity is a client. Is Trinity. Trinity
This is the wallet?
needs the client, Python implementation client. It's the next generation of Ethereum that we might be here this time. So our team, we are working on the sharding client implementation on Trinity. And you can find this on Ethereum. Now it's under Parity. So here we are. Okay. And finally, after the system, after we have some more solid logic, we can try to do some formal verifications and also to audit the whole system. Okay, so how can you contribute to Ethereum 2.0? First, welcome to join the ShardCoin ICO. We will do a re-ICO pre-sale on August 7th.
Seriously?
Yeah, so if you hear that, no. We won't do a re-ICO. Yes, you can actually do for sharding. Is that first go to Research Discourse to join the discussion and see that cute avatar that's Vitalik, that's Justin, to join the age cutting discuss on research. And the second is that our implementations, there are two related repository. One is the Ethereum and Sharding. So it's the Sharding Manager contract utils that we are currently working on. The second one is that the Trinity Python implementation. Okay, and also if the free contributor, free developers, they can actually get some money from Gitcoin. So Gitcoin is a very interesting project that so developers, you can register on Gitcoin, and then the GitHub project owners, they can open a bounty for some specific task, some issues on GitHub. And then the developer, they can climb to that, hey, I want to solve these problems. Please let me do it. And then if they actually, their pull request actually works and being accepted, then they can get Ether from Bitcoin. So that's something that's very cool. You get paid and we are happy. And there's some other ongoing implementations from different organizations and developing, they are working on different languages. And there's a Gitter channel here, with research, Ethereum Sharding. Oh, so this is the 2 months ago that we had a workshop with other client implementations and other researchers, sharding researchers, developers. Look at that, they are so cute. Look at what he's doing. Okay. And also, Ethereum Foundation, we provide grants for some topics. We encourage people to team up and apply for team up to solve those problems like scalability, usability, and security. And something interesting is that if you already have a job and you don't want to quit your job immediately, but also you love Ethereum, then you can apply the 10-week, 10 grand externship for your spare time, and you're working on Ethereum. And this link, I will post the slide after the presentation. So there are other grants for Ethereum related from other organizations. Okay, finally, Ethereum researching, we are kind of hiring, kind of. So our team lead are Vitalik and Vlad, the Vitalik and the Vlad, and we work remotely over the world. Some people in San Francisco, some people in Europe, some people from Cambridge and Singapore and Taiwan, and some people are working on the plane. So it's very interesting. And as you can see that there's so many challenges here and also many opportunities here. And we are looking for the people, the blockchain researchers, the P2P masters, and the experienced Python engineers. So if you are interested in joining the team, then you can email to that account with a subject like sharding. Okay. Thank you.
Our next speaker is Chih-Cheng, and we'll talk about the Casper. And we'll take a break after this talk, 10 minutes break. 好，那我继续讲。好，我继续讲。对，随便介绍一下，还是你要可以讲那个，就是2楼有一个那样的看子，然后对台机上。Okay, because there are 2 people here, so we have another room. You can see the live stream at the 2nd floor. So if anyone, there have a air conditioner. Yeah. So
layer 2 solution.
Yeah, and level 2.
Layer 2 solution. Ouch.
还有线，
在这里。
可以对放吗？
所以你要用英文。
跟我吗？知道大家离开位置就没有位置了。
你可以坐我的位置。
我拿电脑。Sorry。
还有号码。今天我是卖出来主要那个，
2楼可以看直播的。
走，让。
那刚有人在外面。刚有人在外面。对。
刚才到2楼看直播。
现在去2楼看一下。
Thank you, Hsiao-Wei's awesome talk. About more than 3 weeks ago, when we planned to give this talk, I was implement Casper FFG contract with Danny Ran and all the team's contributors helping us. And then 2 weeks ago, if you follow the Reddit forum, you will know last weekend that we have a new roadmap change. So most of our implementation are deprecate somehow. So today I will focus more on the high level concept instead of specific implementation. So my name is Chih-Cheng, and I'm working on Casper. And if you are interested in contributing to the existing or future Casper related works, please contact me on GitHub or Twitter. Okay. So, what is Casper FFG? Today, mostly I will mention three things in this talk. One is give a brief introduction to Casper FFG, and then I introduce a life cycle of a validator, and then is some resources that you can start contributing on. So Casper FFG is a proof-of-stake finality protocol. For proof-of-stake, it means we are making some decision with ethers. For finality, we are talking about we are adding some checkpoints on your blockchain. So the Casper FFG can be layered on a proof of work blockchain. You can also layer on any blockchain with any block proposal mechanism. That is no matter how you block are produced, you can always use FFG to produce checkpoints for you. So in the new roadmap, we will layer Casper FFG on a beacon chain mentioned earlier. So why we need proof of stake? The first simple reason is mining use high energy. Of course, when you run a financial system, you need some cost, but energy has some externalities that cause environmental impacts. So we want to avoid mining energy use. And the second reason is that this is the best part of proof of stake. You can burn assets on chain. So if this helps to reduce centralization, if you have some wealthy validator and trying to do something bad, you can design a protocol that tries to earn its assets instead of doing nothing to the mining rigs in real world. Okay, so in a proof of work, you need miners can large miners can have more R&D efficiency in creating hashing powers. But in proof of stake, a dollar is a dollar. You have no economic scale. So this also further prevents centralization. And why we need checkpoints? This can give the blockchain explicit economic finality. So remember in proof of work chain, your transaction is confirmed like after 6 or 7 blocks, and you call it it's 99% it won't be reverted. And so you don't have a concept of finality, but in Casper in checkpoint you can have finality. So when the checkpoint is finalized, your transaction is really finalized. It's confirmed. And also it helps scaling. When you are doing sharding, you have sharding headers, and if they are if you can provide a checkpoint to finalize those headers, the system will be more secure, and you can do more scalability. Okay, so how this checkpoint is created? So the client will look for the highest justified checkpoint. This checkpoint is to help client determine the fork choice. The client always choose the highest fork, highest justified fork. And then you have some validators. They have deposits of ethers on the Casper contract or on the state of chain. And they have to vote every 50 blocks or arbitrary epoch numbers. You can have five blocks at epoch or 50 blocks at epoch. And then when there are 2/3 of votes are voting for a source checkpoint to a target checkpoint, the target checkpoint get justified too. And then when the 2 epochs are justified consecutively, the other checkpoint gets finalized. So the finalized checkpoint cannot be reverted. If you are performing a 51% attack before the finalized checkpoint is useless, because client will choose the highest justified and finalized checkpoints. Okay. So life of a validator. A validator, you can here we try to answer a question how you become a validator, and how you start doing voting, and how you can quit a job as validator. So the first thing you have to do is you deposit some ether in the on the blockchain, and also you prepare 2 keys. One is to do the voting, and one is for the withdrawal. And we have a minimum requirement for the ether deposit. So you need to have more than 32 ether to deposit on chain to become a validator. And then you wait for 1 day, and then you start voting. In a new roadmap, a validator needs to do more stuff than it used to be. You have to finalize mention, and you also have to verify blocks on shard chain, and you also propose blocks on mention and shard chain. And make sure the cross links is valid. The cross link is some links from the shard chain to main chain. So these are responsibilities for validator. So here are some reward and penalties to make sure the validator is doing the right thing. So if you follow the protocol, you vote normally, you got rewarded. If you don't vote, there are two possibilities. One is that you might be censored, and one might be you are being lazy, you are not doing your job. So we have a slightly penalty for a deposit. But if you are vote contradictory messages, that means if you are voting like you are supporting this fork and you are voting to support another fork like that, you will get heavily punished. It's called slashing. Okay, so when you you want to you need some money to buy a house and you don't want to be validator anymore, you can start logging out. By logout, you can trigger a logout with voting key or with withdrawing key. But you have to validate for another 7 days. And then you have to wait for 4 more months, and then you can successfully extract your deposit. This is to prevent some long-range attack. That make sure you don't suddenly coming back for another fork, because in another fork you will not log out. Okay. So how can you contribute Casper? Well, we were having a repo. This is the original Casper repo. If you heard of something like we are reducing block reward from 3 Ether to 0.5 Ether, and that's EIP 1011, and the implementation of contract lives in this repo. But we currently stop the development here, and trying to do a new implementation. But you can still play around here and to understand some issues that when we do Casper on the current main chain. Okay, deprecated. Also, try to reach us on Gitter if you're Casper. This is still working. I think in a future roadmap we are still have discussion in this Gitter channel, and we have many very good contributors, developers all around the world, and start reaching out to us in this way, and they eventually solve some issues and submit good pull requests. Wait, everything. And okay, so in a previous implementation, if you want to play a testnet, Parity has a implementation, and you can see the network status and the validator log. That helps to understand how validator works. And stay tuned on the ETH research. So the new spec of Casper might come out any moment in here. Thank you for listening.
So higher, so you're depositing at least 32 Ether. Does higher Ether deposit imply high probability of getting reward?
Yes, the reward is proportional to your deposit.
So the rich get richer?
Proportionally
Get richer.
get richer. But this is same as
51.
this is yes, same in the proof of work world. It's the same logic, and in proof of work, in the richer they can use a lower cost to generate more hash power. Yeah. So in Casper, it's more fair in this perspective. Yeah.
What's the major issue that you want to change the repository from the Casper's model?
Yeah, I should talk about the previous Casper. So in previous Casper, we have a smart contract called Simple Casper, and it's deployed on the current main chain. And it handles all the validators, voting, slashing, depositing, all the logic of Casper. But in a new roadmap, Casper is combined with Sharding, and Casper will live on a beacon chain. And the validation logic will not implement it in EVM.
So this will be part of a big contract, like a contract or something, or a layer one solution?
Yes, on big contract, but it won't be in the form of a contract. It will I think it's a native type of big contract. Yeah.
When do you see, Ether holder can start staking?
Sorry. Soon. Yeah.
Thanks, Chih-Cheng. So if you have any other question, you can come here to chat with me. And we'll take a 10-minute break, and we'll start next talk at 8:30.8点半。所以先确定，还没。 I think we can, however, I think we can start the next talk. And the next talk will be presented by the Nagun. And the topic is the past, present, and the future of ICOs and cryptoeconomic token models.
大的，然后另外一个。
Go. Go. All right. Good evening, everybody. My name is Nagu. So today I'll be presenting a little bit about the past, present, future of history of ICOs and especially the option models under ICOs. I kind of gave this presentation to a small private group. So I see maybe 2 or 3 faces. So if it is too repetitive for you, you can probably don't say anything. But I have changed about 30% of the slides, so there's some new material. Okay, good. One other thing, if I am speaking too fast for you, just raise your hand, then I can speak slowly. So today's talk, I tried to cover, about 15 slides in the next 35 minutes, and then we're going to launch a real demo on creating a token and deploying a smart contract and participating in an ICO. But that particular ICO is a price discovery model with interesting crypto economic incentives, some game periodic incentives kind of structure. So with that, let's jump into stuff. So today's agenda, I'm going to briefly introduce myself, and we're going to go through some past history and what's happening in ICO currently now, and then where it is going in terms of interesting economic models, and that's me. I'm a mathematician with a cryptography and AI background.
Nice name.
Nice
Chinese name.
Oh, thank you. I mainly work in terms of blockchain, protocol, security engineering, smart contract audits with respect to blockchain stuff. With AI, I'm a long time AI researcher, practitioner, probably before AI was sexy, 20 plus years. I can.
Advisor to Viking Cruise.
Correct. I used to run their digital team. Now I'm a fellow AMS member, IEEE. But before that, this is a standard disclaimer. So, but I have to just follow through it because of it's a nice thing to do. So this is not a formal advice, financial advice, legal advice, or investment advice. The cryptocurrency tokens are extremely risky assets.
You may also win a lot of money in the very long term.
So with that out, let's jump in. So quickly, just looking at the underlying whole ecosystem. So in 2009, we have Bitcoin, that's the big bang, and for 2 years we haven't really seen anything. And then the first altcoin implementation came with Litecoin, which is a very cosmetic changes to the Bitcoin protocol. Nothing crazily innovative or anything else. And then we definitely start to see some very early stages of inflection point in terms of more complicated, interesting protocols being proposed in terms of Mastercoin, Next, and big shares. And many of the Ethereum founders, Cardano, and many people originally kind of at least started there in this area. And then we have this wonderful event in 2014 the Ethereum was born. And then, of course, it's got become live in 15. Then again, we have 3 or 4 tokens launched in 15, if I remember right. But Digix, Augur, Maker was the 3 main things. Digix is basically a gold asset-backed token. Augur is a prediction market. MakerDAO was essentially sort of stable coin. They all raised like a $1 million when they actually launched these things. Then 16, then the ICO fundraising was somewhat similar but a little bit higher. First Blade was an interesting project too because they actually had contributed a lot in a very different way. Many people who use standard ICO contracts were actually originally written by them. So you see a lot of design patterns, coding patterns originally came from there. Golem is an interesting cloud computing blockchain project. And then we have this big Cambrian explosion in 2017 with million different token projects. But it's interesting to just walk through them, what's exactly happened. For example, Gnosis, it's another prediction market like Augur. They sold 5% of their entitled supply and immediately valued at around $400 million or something like that. And when they hit the market, they were pretty close to $2 billion market cap. Then BAT was basically sold out in, if I remember right, 1 hour. And they raised about $65 million. AdCoin literally sold out in 1 block. That's crazy. They raised close to $65 million at that time. Bancor, they were sold out like in 3 hours. They raised, I think, $55 million, and then $10 million came from additional private sale investments. Status is another big example because since Status, something fundamentally changed in 2017. Until Status, practically every ICO were very poorly designed for token sale mechanics. What basically means is literally ICOs getting sold out in 1 block or 2 block or a few minutes. There's no easy way to participate in. It's all because of very poor design of the underlying auction model and the token sale mechanics. So Status actually saw that problem and spent at least another 6 to 8 weeks just to get that correct, but they screwed it big. When they actually launched ICO, the entire Ethereum network was down for 2 days. So it was, again, very bad execution. And then 0x came, there's something fundamentally changed at 0x too. They raised only $15 million, but around the same time, mainland China came with certain kind of regulatory compliance, so they had to return $5 million. So I think total they raised about 10 million at that point in time. And they only wanted to raise 15 million. They could have raised a lot more. But 0x also did something else, which is they introduced KYC AML as a first step. Since then, practically everybody started to use KYC AML in some form. And today, practically everyone does it. The other big thing changed around this time was the venture capital partners and their employees were basically cutting very deep discounted deals directly with the ICOs. So literally, they could get 50%, 100%, 200% bonuses, and that all started with Status. Status literally gave 200%, 300% discounts to some very big venture capitals. So since then, we start to see these very non-transparent, VC-driven, deep discounted deals practically in every ICO. And nothing has improved from token sale mechanics perspective. It's still very poor. But what happened is that a lot of private pre-sale is coming right now. So you will see, you'll still be able to contribute something. So today, practically ICOs are heavily dominated by venture capital partners. So that's the story today. Essentially, you raise multiple rounds of private pre-sale, whatever you want to call them, through venture capital, angels, and accredited investors. And you show some traction on your token or blockchain, and you cleverly manufacture some utility, and you pull a public sale essentially to make the private sale die switch. You try to exclude certain jurisdictions depending upon a project. But essentially what we end up doing here is we recreated the traditional startup financing model. So we ended up in the same pile of shit that we wanted to change. So this is terribly bad. While it is, so I would like to talk a little bit about where the models are going. It's quite interesting how some of the token models are coming out. But before that, if there are any questions, I'll quickly answer. All right. So future. So there is a very interesting topic getting brewed, which is not very easily visible from outside the United States, but it is. Security tokens. So what are security tokens? Well, security tokens are securities. Basically, they are blockchain-based representation of value, subject to security exchange laws. So next 2-3 slides, when I talk mainly about security tokens, I'm primarily talking with US SEC compliance as a grounding principle. Most of the security acts were actually, we will say, amended from US security laws, so it's easily extendable, applicable, and there are a little bit of extra principle gets applied for countries like Singapore, Taiwan, Hong Kong, Japan, because of underlying custodian counterparties. But otherwise, mainly similar first principle as US. So essentially, there are two ways you can launch a security token, which is a pure security. Essentially, you give a security offering, or you raise a security exemption for your offering. And there are 5 classes of exemption. Each class approximately can get you $50 million US. But typically, each class has certain different kind of requirements to comply. If I'm correct, I think regulation A+ or regulation CF can get you only like a 1 million or 2 million per year, with some additional requirement on who those contributors are. But otherwise, regulation D, regulation S, and Rule 147 can get you 50 million each bucket. So what typically people are doing, essentially, they will raise this exemption under each class and raise $50 million in an interesting way, which is in US, you can raise money from any accredited investors. Outside US, you can practically raise money from anybody for a project in the US. So with that, so there's a lot of things happening. It's practically ends up, maybe we may see a very widespread adoption of security tokens across many different asset classes. In fact, we probably end up creating a ton of more asset classes we ever envisioned. In our society, how we claim ownership, how we transfer those ownership claims probably may fundamentally change when these security tokens are widespread for different kind of asset classes. There are few very important benefits or characteristics of these security tokens. Essentially there are 24/7 markets. You can have a very granular atomic fractional ownerships with these security tokens. For example, take REITs. REITs are essentially you group a bunch of real estate properties to pool the risk, and you issue some shares, and you basically buy those shares. But the share represents a pool risk. It doesn't represent a granular, atomic, tokenized version of individual real estate property. But in a tokenized real estate as a class, you could actually do that. You could go to a very atomic level fractional ownership of that underlying real estate property. Of course, rapid settlement, instant settlement. There's a massive reduction in issuance costs for tokens as a security. Of course, another big property of tokens is they are instantly global. So you have a large liquidity and a greater market depth. With the introduction of smart contracts and other, you could have automated compliance, inter-asset interoperability. There is also a very interesting concept. It's called the complete contracts in economics. A complete contract is basically, in general, most of the business contracts are called incomplete contracts because you cannot exactly specify all the underlying agreements for now and also future. You only specify the core and then you leave it for later for disputes. But when you actually specify all future agreement restrictions, then that becomes a complete contract, and it generates very interesting properties from a economics perspective. You could actually implement that with tokenized securities. With that, there are a ton of exchanges are already applied, waiting for final approvals to trade these security tokens. You probably mainly heard about D0, but there is Open Finance Trust Token, Securitize, and Templum. There's also interesting protocols are coming who can, essentially they can work like investment bank. They can do your ICO for security tokens on behalf of you, and they'll probably take 10%, 15%, like whatever their cost is.
So what's the difference between Power and Polygraph?
They are two separate protocols. They're two separate platforms. Imagine like two separate investment banks.
So doing the same thing.
Correct, exactly. Yeah. And they have a different pricing model, different structure. So there are already a ton of security token projects. There's a Science blockchain, which is a very interesting incubator blockchain by Mike Jones from LA, Los Angeles. He's a guy who founded Dollar Shave Club and a couple of other big Google exits. There are other funds also. There are security tokens here. Science is one of the first security token to issue an exemption in US, and luckily I happen to be their smart contract security auditor. With that, if you're planning on doing a security token, then typically it's a process. If I don't know, many of you never actually launched a security. So typically, you have to do a lot of groundwork. Hire your advisors, legal counsels, get them to structure your security offering properly, develop your smart contract for all the business logic that you're going to be creating there. Have a proper security, smart contract security audits.
This is not officially SEC standard, right?
Officially,
SEC standard.
this is officially SEC standard.
Is this?
Yeah, these are official regulatory exemptions. the 5 classes exemption under SEC Act.
Oh, so,
Yes.
so doing the security tokenized.
Correct.
Then you actually fit those.
Correct, yeah. Basically, people don't want to directly issue a security offering,
Right.
so they raise an exemption.
Okay,
To
so
only
doing
raise.
the security tokenization,
Correct.
you follow those.
Correct, yeah.
But you mentioned, maybe I didn't get it clearly, that there's a maximum amount, there's a cap of how much
Correct.
money you can raise.
Yeah,
Total amount.
correct.
And
That's-
total as whole group or each separately?
No, total. For example, regulation,
50 million.
correct, regulation D will give you 50 million bucks, you can't raise anything more.
Okay.
Regulation S gives you 50 million, 147 gives you 50 million,
Okay.
but other two are like, they're a little bit more
So you
complicated.
can only use one regulation.
You can use multiple.
So that's more than 50 million.
Correct.
Oh. But it doesn't prevent you from future offering, right?
Correct. You can go a full security offering in future.
And those offering need not to fit those regulations.
Correct, yeah, correct.
Okay.
So these are exemption for going a
Beginning
full
for the
security.
full-
Correct,
full-
yeah. And these are all legitimate companies. These are registered companies
Okay.
under SEC.
Got it. Thank you.
So you need to do proper security audits for the smart contracts because you have now a fiduciary duty because it's actually a security. Of course, develop your market material, do your proper due diligence on KYC, tax rules, reporting information. There's a lot of accountability and responsibility comes with doing a proper security token.
What are the major differences from each exemption? Just like
There are separate classes of exemptions that you could use to raise money. Pardon?
Can you give like an example?
If I am right, the regulation D has a certain kind of profile for the individuals. Regulation S has a certain kind of profile. And regulation S also covers international investors without being accredited investors because only US has a little bit more technical definition of accredited investor. Outside US, that definition doesn't really apply. So I think I have full details on that. I can share with you what those things are. But there are separate classes of exemption that you could use to raise money. All right. The advantage of Harbor and Polymath and others that are coming in is essentially they are like your investment bank. They would do some of these tasks, or in cases maybe in future all of the tasks, and you just have to write them a big check at that time. Then they can basically do your offering for you. But there's a big problem in the industry, at least it's getting addressed in US, but I'm not really seeing anything outside, which is, yes, you can issue a security token, but how are you going to trade? How is it going to get to the exchanges, brokerage, dealership, market makers? There's not much happening here. So practically no discussion happening outside US on how to address these big infrastructure issues. But people are planning to do security token outside US too.
Do you know whether the European Union are doing similar thing or along this line, or they're just...
No, there's practically no discussion on infrastructure as far as I know. London, there was something happening, but not much.
And those are only for corporation, right? So you have to register a corporation, but you cannot do a foundation. Right?
Correct. There's something happened last week, which is the Coinbase. Coinbase acquired 3 or 4 different companies who had essentially a dealer license, brokerage license, and a registered investment advisor license. With all 3 of them, essentially now they can issue security tokens and become a marketplace for trading those security tokens all within Coinbase. And that was basically the announcement last week. So they are literally the the main first player for trading, issuing security tokens. And all the big boys are just standing in the line. So there's something else outside security tokens, which a lot of people like to call utility tokens. I don't really like the word because practically everything has a utility from economics perspective. So these are non-security tokens. There are two ways they can exist. Either they start as a security and then sometime they become not a security, or somehow they become not a security from very beginning. One like a way to think about them is something can be a not a security since beginning if the product is live, network is live, and you're not doing anything that is makes it a security. So think like any like access type tokens that are not pre-issuing, but actually that platform already exists and people are already there on the platform. Now you're issuing a token for access related things. That technically qualifies as non-security from security exchange law.
You're talking about your asset client?
Yeah, I mean you can. Many people are pre-issuing these tokens before their network is live, before their product is live. So there is always a promise of some future return. That's where this is. The other big important thing that was consistently mentioned in all of the congressional talks with SEC and CFTC was they are very clear that the compliance guidelines or rules, they are not written in stone. Means something that looks like a security today from a rules perspective, they might change tomorrow. So they are quite flexible about that. Those proposals to the security.
Crack like a dog, walk like a dog, and not be a dog.
Correct. Tomorrow, but today it could be a dog. All right. So where the future is looking like, probably looking like you raise some private sale round from accredited investors or whatever you want to call it, and then maybe you do a bunch of interesting things like bounties and airdrops and rewards and all this kind of stuff to increase your adoption. Then some meaningful wider distribution, and then get the token in hands of actual people who are going to use it. So that looks like a future, and then there are various ways to do this than what we are currently doing. There is also interesting models coming out for actually doing the options for your token offerings. One was proposed by Wardlack himself around January this year, which is very interesting. We say essentially a combination of a DAO and an ICO. So in a typical ICO, you have, let's say, 100 million token, you sell X percentage, and you keep Y percentage remaining to you. And what happens is when people contribute Ether to you, all the Ether directly goes to your Ether wallet, it's in the founder wallet, and you give the tokens back. In a DAO, basically the underlying organization structure is decentralized. What you can do is you can combine both of them. When somebody contributes Ether in an ICO, the Ether doesn't get immediately released to the founders. So there is a mechanism called TAP. So it slowly leaks those funds to the founders for operational expense, business expenses. So imagine like in some venture financing models, it works something similar. Even though in a Series A, let's say you raised $50 million, nobody's going to give you $50 million check at the end of the day of the Series A presentation. Typically, they put that funds in some corporate accounts, and there is a plan for releasing those funds based on your traction. All those things. So it's somewhat similar. The funds get locked in a smart contract, And then there is a tap and voting mechanism. So the tap is essentially, okay, release $1 million per every quarter to the founders to do the product development. And here is a mechanism for increasing or decreasing that tap rate through this decentralized voting system. So that's the essential idea behind this DICO, DAO plus ICO. There are some problems here, especially the underlying attack vectors or attackers are the developers of the startup itself. Then you could essentially pre-allocate a lot of tokens to yourself and vote in an interesting way. Or similarly, you can give kind of very good bonus for yourself in some crazy private sale or public sale mechanisms. So there's some problems are there, but the capital cost of attacking a DICO model is lot higher than the traditional ICOs. So there are incentives in launching something like this, and this also makes a lot more sense. Instead of giving out 10,000, 50,000 money that you contributed to the founders who have nothing, you give them, 500 Ether to develop for next 3 months, and you set a rate, you give them sequentially, and have a mechanism to increase, decrease that rate based on the project progress. There are many different variations of it. Instead of giving Ether, you peg it to a stable coin, and you actually give them dollar, Taiwanese dollar, euros, Chinese renminbi, things like that. There is also like an iterative way of doing these things, DICO models. And again, you can bring a very interesting game periodic way of assigning different payouts for the contributors and founders. There's another thing that is very much underutilized in practically all the ICOs is price discovery mechanisms for the initial coin price, the price at which the coins are actually sold. For some reason, many projects they just don't like it, and economics tells us that this is actually one of the best model for maximizing the utilities on all sides of the game. But there are projects like Raiden, Polka, and a couple of other projects who actually used the price discovery models. They're sometimes called Dutch auction models or modified Dutch auction models, or sometimes they call second price auction model. For example, your Google ad algorithm is a second price auction model. Means you always pay the bid price who is just behind you plus maybe a 1 cent extra. So in a price discovery model, essentially everybody is bidding at a different price as the time passes, and when you finalize the auction, the final price gets recalculated across how much is collected and how much is sold, and then that final price get applied to all the tokens and then get redistributed to everybody. So that's what we're going to do today in the demo with a little bit of time-dependent economic incentives and some game periodic things and all those kind of stuff. And if you get a chance to spend a little bit of time in the code, we'll see, but probably we already have 2 technical presentation. I'll leave technical details aside. You just participate in the ICO. But before that, I would like to do a quick time check. How much time do I have? 20 minutes, 30 minutes? 10 minutes?
10 minutes or 20 minutes is
20 minutes is okay. Okay, I'll quickly run through some regulatory update details and then probably launch the ICO. So in USA, there is this term getting formalized called pure cryptocurrency, which is like Bitcoin, Ether, Dash, which is a pure payment currency. And then we already talked about security tokens and not security tokens. Exchanges need to be either a national exchange or ATS, alternate trading systems. In US, there is also very bad implementation of money transfer business license law, which is every state have their own money transfer regulatory compliances. So if you're a business, you need to get approximately 38 different money transfer service licenses from each state separately to be able to work. But there's a proposal to basically simplify that and then just issue one MSB for that. FTC launched a new task force for blockchain, and there's a new head for that. Thailand just proposed new ICO guidelines like 2 days ago, surprisingly quite detailed. I'm not sure how they pulled up all these numbers and facts, but we have extremely interesting guidelines from Thailand. Essentially, you could do ICOs. There's trading is also allowed officially now. There are 7 currency pairs are chosen for now. They will expand more. There are mainly 2 different kind of licenses: crypto exchanges and the brokers and dealers license exchange. For crypto exchanges, you have approximately 150K upfront for token distribution and operations, and there's a trading volume fee. If you want to do an ICO, you need a 5 million Thai baht for reserve capital, which is approximately 150K USD. Surprisingly, they kind of relaxed the VAT on any kind of cryptocurrencies. So that's very interesting. Oh, another important thing, there is practically no limit on how much money you can raise in ICO through this new framework in Thai. So, Lithuania has another set of guidelines literally like yesterday. Again, there's formally announced there is no specific ICO legislative body. It has to go through the Lithuanian Central Bank. They define certain kind of rights. If any of those rights are qualified, then it's a security, otherwise it's not. There's interesting taxes guidelines too for this ICO. Practically every ICO company don't think about taxes, but it's very, very important. And there is no taxes on crypto mining in Lithuania. So there is interesting flow they proposed for securities and non-security tokens. Swiss had a similar framework, but they had 3 classes of tokens: payment, asset, utility. But there is very little official explanations on what exactly they are. So it's very, very difficult to find any information with them. Estonia also has a very similar structure as Swiss, but again, very little information outside of what they proposed in their 4-page document. This is my contact info. If you want, you can contact me for any questions, advice, whatever. I will be able to help you if I can. And with that, I'll open for questions. If no question, then I'm going to show you a demo. And I'll probably need 10-15 minutes.
What's the demo about?
I'm going to launch an actual price discovery ICO, a smart contract.
Very short time.
Yeah.
Okay, sure.
All right. Can you hear me?
Yeah. Yep.
All right, great. So it's a ERC20 token, compliant token, with something called uniform price Dutch auction. What basically means the final price when we're going to uniformly apply across all the contributors and redistribute the token to them. And then let's get back. So I have already a private net running here. So I kind of wrote the smart contracts. All I need to do is deploy them and then participate in it. So for that, I can create a simple structure. Mainly, I have some pre-sale accounts, pre-sale participator, and the public sale user 1, user 2. I have the main wallet, which is a multi-signature wallet that's basically going to collect the contributions, and I have a whitelister for private sale whitelisting and a public sale whitelisting. We're going to be launching the contracts from the wallet account. Right. I'm going to deploy a Dutch auction. So what here is a Dutch auction is the price starts very high, probably literally 1 Ether, 2 Ether per token, whatever you want, and each second or each day the price drops, and then you can design this exponential drop however you want. So if you know a little bit of something called nonlinear regression or price curve fitting, you could actually design this for yourself. You just go to an Excel file, put a day 1, day 2, day 3, up to let's say 28 days, how much Ether you want to raise, and then you can actually build a curve. It's a little bit complicated, nonlinear regression, but once you have the curve, you can take the curve parameters and then essentially create a pricing model for that. So I already designed that here. It's a exponentially decaying curve, so it looks like that price as time drops, price drops. So I have basically a wallet address where the money is going to be collected. I have a whitelister address who is going to whitelist our public guys, who is going to actually distribute the tokens at the end. And then where exactly I'm going to start, I'm going to start at 2 Ether per token, and then gradually drop the price. And then I have the price curve parameters already designed here. So we're going to copy the contract address. We need that. Next, we're going to go back and deploy our token. This looks like magic if you have never deployed a contract, but bear with me. All I'm doing is, I already wrote the smart contract. I'm going to Ethereum wallet and just deploying them, and that will create your smart contract addresses. So then you can essentially participate nicely. So we need our contract address. We need our wallet address. So all I'm saying is, I've taken the auction, connecting it to token. I'm going to take the token, connect back to auction. I don't know, maybe 100 million. Let me make sure I am deploying from wallet. Yes. Good. Go back to, you could see we initiated 100 million supply. That's our ShardCoin token. If we go back to our auction, you'll see there's a ton of variables that are just stating idle for now. The state variables for the auction. We're going to basically set up the auction, which requires us to connect the token address, and we're going to link it from that. Right. Good. You'll see 50% supply is basically moved to the auction contract. You'll see number of token auction. So, and we have various kind of functions here. Basically, we have to do some whitelisting for private sale guys and public sale. I'm going to do whitelisting and probably place a transaction and then stop there. Okay. You could actually see it's working this one. So the contract whitelisted those addresses. Doing a public whitelisting now. Good. So the way I've written contracts are the private sale guys can contribute at any part of the auction, before actually auction started, because that's an important thing to design, so that you could reduce certain issues related to the sale mechanics, so that you can receive your guys that that you're going to be giving a sweet deal, get their money faster. So technically we could go to bidding and pick a pre-sale guy and give them $1 million. This should go through, and it went through. So we actually successfully submitted contributed 1 million Ether to the contract address, and there is a bonus here, 25% based on the timing and private sale whitelist, things like that. So that's why you see amount with bonus. So at this stage, auction is not started. So if we actually do a regular user bids, we're going to get an error. Just to show you, if I do this, I should get an error. Correct. we launched the auction. This is a cash problem. So I'm basically saying public auction is getting kick-started. Okay. You could see the auctions time previously was 0, now it's started. Now a regular user can actually go and make a an Ether because I'm very poor. Good. So that went through. So essentially now it's going through an exponential decay curve as the time passes, rate changes when there is a contract function for finalizing the auction that finalizes the final Dutch auction price and recomputes the tokens, and there is a governance mechanism for essentially distributing it. So it's a nice way to do the price discovery of this interesting Dutch auction model, second price auction model. Uniform price is not the only price where you can do. You can, especially in economic literature, there are very, very interesting auction models that you can implement, but I haven't seen anybody even attempt to do any auction models. So I'll stop here because the rest everything is just submitting transactions. See? Questions?
Okay, thank you.
Oh, thank you.
Thank you. We'll have this place till maybe 10 o'clock, so everybody can have a chat, and thanks for coming.
Thank you, Mel.
What is your conclusion in the for the future? You know that one is security token, the other is non-security. In your series, your presentation, one is security token, the other is non-security.